now that we have seen how to find the derivative using the definition of the derivative, let's look at some question which uses the derivative. So a very, very common question you're going to see in this class is to find the equation of the tangent line. Now, remember that the slope of the tangent line is the rate of change, the instantaneous rate of change. But remember, I don't have to write that, it's assumed, which is the derivative. So when you when you're trying to find the equation of the tangent line, you need to find the derivative because the tangent line is associated to the derivative. So the first thing we're going to do is find the derivative. So here we have, let's write the formula. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Now, just like I did in the last video, I'm going to find f of x plus h first. And it's going to be 2 minus 3 x plus h squared. So I'm going to FOIL out x plus h, which is going to give me x squared plus 2xh plus h squared. And I'm going to distribute the 3. And again, be careful here because you're distributing it in negative 3. So now you can put that into the formula. So I have the limit. So it's going to be 2 minus 3x squared minus 6x minus 3h squared. And then minus, and I'm going to put in my f of x. And don't forget about your minus here, okay? When you're putting in parentheses. And this is all over h. So this is going to equal to the limit as h goes to 0. I have 2 minus 3x squared minus 6x h minus 3x squared. I'm going to distribute the negative. So it's become a minus 2 and a positive 3x squared all over h. Here comes the magic of the difference quotient. The negative 3x squared cancels with the positive 3x squared. And the positive 2 cancels with the negative 2. And I am left with the limit as h goes to 0. And I can see that my two terms that are left, which is right here, they both have an h. So I'm going to take out that h. I'm going to be left with a negative 6x minus 3h over h. Here comes the magic again. The h's cancel. Now I can plug in h equals 0, so negative 6x minus 3 times 0, and I get a derivative of negative 6x. So my derivative, f prime of x, is negative 6x. So that's actually step number 1. So when you're doing this type of question, step number 1 is going to be to find the derivative. Step number 2 is going to be to find the slope of your tangent line. Because remember, the derivative is the instantaneous rate of change for the entire function. But you're looking specifically for the tangent line at x equals 1. Let's highlight it. Here it is. It gives you an x and it will give you an x for these types of questions. So you have the general instantaneous rate of change. You have the formula for the instantaneous rate of change. So how do you find it for your specific x? Well, you plug in x. So the slope of the tangent line will be f prime of 1, which will be negative 6. And the last step is to do the algebra, which is to create the equation of a line. So to find the equation of the line, you can do so if you have the slope and you have a point. Now, I know that my slope is negative 6. I know that x is 1. The only part that I'm missing is I don't have y, which is very easy to find. The way that you find y is you plug x into the original. Anytime you're looking for the y coordinate, you plug it into the original. So I'm going to do that here, f of 1. And that's going to be 2 minus 3, which is negative 1. So my y is negative 1. And then we have a formula called the point slope formula. It's y minus y1 is equal to m times x minus x1. And the point is denoted by the x1, y1. So if you want, you can call this x1, y1. So it becomes y plus 1, because it's minus minus, is equal to negative 6x minus 1. And most of the time, these questions are going to ask you to put it in slope-intercept form, so you need to isolate the y. So this is going to become y plus 1 is negative 6x plus 6. I'm going to bring the 1 over by subtracting it. So it's going to become y is equal to negative 6x plus 5. Here is my equation of my tangent line. So my function is 2 minus 3x squared. And at x equals 1, the line that lies on top of the graph at x equals 1 has the equation negative 6x plus 5. So anytime you're doing these questions, which you're going to be doing a lot in this class, remember your 3 steps. Step 1 is to find the derivative. Step 2 is to find the derivative at that specific x. And step 3 is to plug in your goodies into your equation of a line. All right, let's take a look at another very common question, which is find the x value where the tangent line is horizontal. Now, what I want to make you aware is, again, the tangent line is included. So tangent line means you're going to use the derivative. Now, the function is exactly the same function as number 1. So we don't need to find the derivative again. There's no need for that. We already found it. Let's just rewrite it. Let's not do that to ourselves. Okay, so the difference in number 2 versus number 1 is that in number 1, the x is given to you, and you need to find the slope. Because to create an equation of a line, you need the slope. So when you're asked to find the equation of the line, it gives you x, you find m. In number 2, it's the opposite. You need to find x, and m is given to you. But you might be like, no, it's not. Where is m given to me? It's given to you in the keyword that the line is horizontal. Because we know, hopefully, that when a line is horizontal, the slope is 0. So in this one, this would actually be only 2 steps. Step 1 would be to find the derivative. Step 2 is to take your derivative and set it equal to 0, because the derivative is the slope. And when you solve for x, you get x is equal to 0. So we only have one x. The only place where the derivative is 0 is at x equals 0. And again, it asked me to find only the x. I don't need to find the entire point. So I am done. So quick recap. Find the equation of the tangent line. You're given x. You're finding m, and then creating the equation of the line. Find where the tangent line is horizontal. You need x. You're given m indirectly. So the key to doing well in this question is to remember that a line is horizontal when the slope is 0. And of course, to remember that the derivative is 0. All right, let's do an application problem, a population one. So a 5-year projection of population trends suggests that T years after 2010, the population of a certain community will be P,000, where you're given the following function. At what average rate, so here we are, we're starting to get the average rate, will the population be growing between 2010 and 2012? And then part B is at what instantaneous rate? And I just want to make a note here that it didn't have to say instantaneous. If it just said at what rate, you should know that, so this wouldn't even have to be here. Rate means instantaneous if it doesn't say average. So it's giving us 2 questions. What is the average? What is the instantaneous? So let's do average first because it's a little bit easier. So we have that we're going from 2010 to 2012. Now it tells us that T is the amount of years after 2010. So in 2010, that means that T is 0. And in 2012, that means that T is equal to 2. So to find average rate, we need the difference in y's over the difference in x's. So I have P of 2 minus P of 0 over 2 minus 0. So then we need to find P of 2. Let's do that on the side. P of 2 is going to be negative 6 times 4 plus 12 times 2 plus 151. So that's going to give us negative 24 plus 24. Well, that's nice. Plus 151, which gives us a perfect 151 because the 24 is canceled. And then P of 0 is going to be, all the t's go to 0, so I'm left with 151. So when I put that in, it's going to be 151 minus 151 over 2 minus 0. But this is 0 over 2, and anytime you have 0 in the numerator but not 0 in the denominator, it's 0. Now, remember what this means. The average rate of change does not mean that the population didn't grow at all. It just meant that on average, it was 0. So what could have happened is that from 2010 to 2011, it grew a lot. And then from 2011 to 2012, it decreased. So on average, it grew 0. But it doesn't mean that the population didn't change. Now, the next part, what is the instantaneous rate of change at 2012? That means that we're going to have to find P prime of t, because the derivative is the instantaneous rate of change. And because we're looking specifically at t equals 2, we're going to plug in t equals 2 into the derivative. So let's go over here where we have a little bit more space. So P of t is negative 6t squared. Let me just double check. My plus 12t plus 151. So let's get our definition of the derivative. So P prime of t is equal to the limit as h goes to 0. Here I'm going to go directly into plugging everything in. So it's going to be negative 6 t squared plus 2th plus h squared plus 12t plus 12h plus 151 minus, and then I'm going to put this in parentheses. I keep explaining how important it is. All over h. So we got to clean that up. And it's going to give me negative 6t squared minus 12th plus h squared plus 12t plus 12h plus 151. Distribute the negative, a positive 6t squared, a negative 12t, and a negative 151 all over h. Here's when the magic happens. The negative 6t squared cancels with the positive 1. The positive 12t cancels with the negative 12t. And the 151 cancels with the negative 151. And now every term that's left has an h. So I'm going to factor out that h, I should say, before I cancel it. I'm thinking ahead. So if you want to highlight this term, this term, this term, all over h, the h is canceled. And now I can put in my limit for h, which is 0. So it's going to give me negative 12t plus 12. So P prime of t, my derivative is negative 12t, but I want my instantaneous rate of change in 2012, which means that t is 2. So when I plug it in, I get negative 24 plus 12, which is negative 12. So in 2012, I have a rate of change of negative 12,000 people. Okay, how do I know it's 1,000? Because it specifically states right here that my P is in 1,000. So because I'm getting negative 12, my rate of change in 2012 is negative 12,000 people. So it's asking me, is the population increasing or decreasing? And the answer is decreasing because my rate of change is negative. It's decreasing by negative 12,000. And let's highlight the negative just to really emphasize it so I know it's negative, so I know it's decreasing.